Welcome to Your Math Explained, where we make math simple and clear. My name is Julian, and today we'll look at two geometry and measurement problems. The first problem is for grade 9 and 10 students, and the second problem is for grade 11 and 12 students. In both problems, we rely on the Cartesian plane and the coordinate system to find the solution. If you're not subscribed to the channel, please make sure that you like and subscribe to the channel before you watch the video. Pause the video now if you haven't had a chance to read it, otherwise, let's jump in. In this problem, we're given two lines already, and they've defined it for us. Right away, they're already pointing out A, B, C, and D, so it's probably a good idea to figure out what these values are, what their coordinates are, and we can easily do that through exploring the lines. In addition to A, B, and C, it's probably worthwhile for me to figure out what the non-labeled points are, so I'll do that as well. I don't know if we'll need it, but might as well do it. So let's say we're starting with that top line, 3x plus 4y equals 48. By isolating y, we'll get negative 3x plus 48, and then dividing it by 4, we now have our line in mx plus b form. This b value, recall, is our y-intercept. So already we know that this has a y value of 12. That's definitely going to be good information. Let's try to find its corresponding x-intercept. So we're talking about that steeper line. So we can find this one down here by setting 0 to be y. And then we will solve for x. So we've got negative 12 equals negative 3 over 4x. So we've got negative 48 over negative 3 equals x, which is 16. So we know this down here has an x value of 16. Now we're going to switch gears. Let's use the other line, so the less steep one. So we've got x plus 2y equals 22. We're going to follow the same process to isolate y, and we'll get negative 1 over 2x plus 11. So that tells us that we have a y-intercept of 11 for the line that is a little bit less steep, and we can find coordinate c as well using our x-intercept method, so setting y to be 0, and then solving, meaning we'll multiply both sides by negative 2, we'll get x is 22. So we now know that c is 22. Lastly, we have coordinate b that they've identified for us, so we might as well try to find that one as well. Coordinate b can be found by setting the two lines equal to each other, and then finding the x value that allows for that to happen. So using the two isolated equations, we can set them equal to each other. We'll have negative 3x over 4x plus 12 equals negative 1 over 2x plus 11. So grouping the x terms onto the left side, we'll get negative 1 over 4x equals to negative 1, and then multiplying both sides by negative 4, we know that x is equal to 4. We can find its corresponding y value as well by subbing it back into one of these two equations. If we do that, y will be equal to 9. So we know the exact coordinate of point B. Now our goal is to figure out the area of the shaded region, and when I look at this diagram, it's not a nice triangle, but I can break it up by drawing some lines. If I draw a horizontal line here at B, I see that I've created a mini right angle triangle at the top left. If I draw a vertical line at B, I've now created a rectangle, and then another right angle triangle on the right side. So I'm going to call these names just so that we can follow along. This top left, we'll call it M. The rectangle, we'll call it N. And then this big right angle triangle on the bottom right, we'll call it P. And we'll try to find their individual areas using the information that we've got. And then we'll add it up to create the area of ABCD. So with M, well, we notice that it's a right angle triangle. So the area would be calculated as the base times height divided by 2. The base of this triangle M is from 0 to B, which is a distance of 4 units. The height is, well, this was 9, because that was the coordinate of b. So 9 to 12 means there's a height of 3. And then dividing it by 2, this will give us 6 units for m. For rectangle n, well, it's a rectangle, so this is just length times width. We can see that the height of the rectangle is 9, and the width of the rectangle is 4. So that would just be 9 times 4, which is 36. The last one is P. So P is going to have a triangle of base, well, this coordinate here is x equals 4, so 4 to 22. That's a base of 18. And the height is 9, so 18 times 9 divided by 2. 18 and the 9 can 18 and the 2 rather could reduce to 9, so this works out to an area of 81. So our final area is going to be 6 plus 36 plus 81, which works out to 123. And since they haven't provided any units, we'll write units squared. In our second problem, we have a square ABCD, and they've given us some interesting values to make note of, that AE and EF and FB are all equal to 10, BG and GH and HC is equal to 10. So this is giving us some symmetry to work with, which is great. They also make a point to tell us that there's an intersection point J here. So my first instinct when I read this problem is probably to figure out what that coordinate J is, or what that intersection point is at J. For me to find intersection J, I probably want to overlay a coordinate grid so that I can make sense of this problem. So imagine that there's a y-axis right on the left side of the square and an x-axis on the bottom side of the square, making coordinate D here 0, 0. Now we've actually got coordinates for everything. Specifically, F here, that's going to be the coordinate 20, 30, and H would be 30, 10, and C down here, that would be 30, 0. And those are the three notable points so far because they are points that lie on the square. If I'm trying to find coordinate J, it probably is a good idea for me to figure out the equation of the lines. So I'm going to start with DF. And when I look at that, I see 0, 0 to 20, 30. So one of the tools that I'm going to rely on is going to be our slope formula, which is y2 minus y1 over x2 minus x1. This will quickly allow me to find the slope of each line. And because it's y-intercept at 0, it'll be easy to create the equation. It's merely the slope times the x value. So when you insert the numbers into the slope formula, we'll get 3 over 2 as the slope. So already we know that df is y equals 3 over 2x. We can do something similar with dh, because it's 0, 0, and h has the coordinate 30, 10, so we know that y is equal to 1 over 3x. The line that we haven't done yet is FC, and that probably is the one with the most amount of work because we've got two coordinates that aren't 0, 0, and we'll have to use the calculations to do that. So the slope formula here would be 30 minus 0 over 20 minus 30, which works out to negative 3. And one helpful tool for writing the equation of a line is the slope point formula. That's y minus y1 equals m times x minus x1, where m is the slope, we know that already, and the x1 and y1 is just any coordinate on that line. So I'll pick the 30, 0, so it would say y minus 0 equals negative 3 times x minus 30, and when I simplify that, it'll be negative 3x plus 90. That's perfect. Now we've got 3 lines, and this paves the way for us to find coordinate J, which was the original intention. So J is the intersection of line FC, which is the negative 3x plus 90, and DH, which was 1 over 3x. So we can do a little bit of solving here. We'll get 90 is equal to, so when I add 3x to the other side, I'll get 10 over 3x. And then times 3 divided by 10 will give us x is equal to 27. And if I have the x value, I can put it back into one of those original ones. So I'll put it into this one. That's an easy calculation. Y will be equal to 9. So we've got the coordinate of 27, 9. Great. So what are we going to do next? Well, we're trying to find the area of the shaded region. So looking at the fact that this is a square, when I look at the white regions, there are 2 right-angle triangles. And by finding coordinate J, I actually have the height of this bottom white triangle. It's probably easier if I subtract the white area from the square to find the remaining area, which is the blue part. So again, we're going to call this M, N, and P, and we'll try to find those corresponding areas. We'll start with M. That is a right angle triangle, and we know the base and height already. The width of that triangle is 20. The height of that triangle is 30, and we'll divide that by 2. So that is giving us an area of 300 units. The one at the bottom, which we called N, has a base of 30, and the height is defined by coordinate J, which was 27 and 9. So the height is 9 here. So we'll multiply that by 9, divided by 2. So 30 divided by 2 is 15. 15 times 9 will give us 135. Lastly, we've got P, and that's actually not a triangle, but really it's a quadrilateral. So we're going to have to do a bit of a splitting method here. If I draw a line right here down to J, this creates a right angle triangle, and we'll also create a horizontal line here to H. So now we've got 2 right angle triangles and then a rectangle, and that will make up area P. So we'll do that down here. P, so the leftmost triangle, which we will find, is this one first. The width of that triangle, well, since this had a width of 27, coordinate J had a width of 27, and this had an x value of 20, we know that the remaining distance to be traveled here is 7. So we've got 7. And then the height of that triangle is 30 from up top all the way down to 9 at coordinate J. That means there is 21 units there. We'll divide that by 2. Now we're going to focus on this mini triangle down here. That has a width of 27 to 30, so that's going to be a width of 3. The height of that triangle is 9 to 10, so that'll be 1 divided by 2. And then finally, we've got the rectangle. So we've got a rectangle that has a width of 3 and a height of from 30 to 10, so that's 20. So when we add up all of these numbers, we are going to get 7 times 21 is 147, plus the 3 would be 150 over 2. So that's the 75 and the 60 from the rectangle. Great. Now we need to take M, N, and P and subtract that all from the area of the square. So the area of the square, because it's a 30 by 30, that'll give us 900. And so our shaded region is going to be 900 minus the ones that we've calculated. That's minus 300, minus 135, minus 75, and minus 60. And because they want the fraction that was shaded, we just have to make this all over 900. And so this works out to 330 over 900, which simplifies to 11 over 30. That wraps up this week's problems. Check out the problems I've posted for next week's video. Try them on your own first and see how you'd approach them. And as always, if you found this helpful, don't forget to give this video a like and subscribe so you don't miss the next one.
That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.